Have you ever wondered how systems manage to reconstruct every single change that ever happened, not just the current state? In a world dominated by traditional create, read, update, delete, or CRUD operations, we often lose the rich history of why and how things changed. This often leads to complex auditing challenges, difficult debugging, and limited analytical capabilities. But what if we could capture an immutable chronological record of every business event? That's where event sourcing comes in. It's a powerful architectural pattern that fundamentally shifts how we persist data, moving beyond just storing the current state to preserving an entire history of changes. This deep dive will unravel the core principles, explore its building blocks like events, commands, and aggregates, and look at practical applications. We'll see how it enhances auditability, simplifies debugging, and provides a robust foundation for advanced system designs, setting you up for a more resilient and insightful architecture. At the heart of event sourcing lies the concept of the immutable event log. Imagine a ledger where every entry is a fact, a statement about something that has already happened in your system. These aren't commands or intentions, they are past tense, undeniable truths. For example, order placed or item added to cart. These events are stored sequentially in an append-only data structure called the event store. This store is the single source of truth. You can only add new events, never modify or delete old ones. This immutability is crucial, guaranteeing a complete and accurate history. So how do we get the current state of an entity, like a user's account balance? We simply replay all the events related to that entity from the very first one up to the latest one. This process, called rebuilding state from events, allows us to derive the current state on demand. It's a powerful separation of concerns. Commands express intent, while events record what happened. Let's break down the essential components that make event sourcing work. First, we have commands. A command is an instruction, an intent to change the state of your system. Think of it as place order or change shipping address. Commands are imperative and typically target a specific entity. When a command is successfully processed, it results in one or more events. As we discussed, events are immutable facts like order placed or shipping address updated. They are the historical record of what did happen. To ensure consistency, commands are processed by aggregates. An aggregate is a cluster of domain objects that are treated as a single unit for data changes. It acts as a consistency boundary, ensuring that all business rules are applied correctly when a command is executed. For example, an order aggregate would handle commands like add item to order and emit events like item added to order. Finally, event handlers are components that react to events. They might update read models, trigger side effects, or send notifications. This decouples the act of changing state from the reactions to that change, leading to more flexible and scalable systems. A common misconception about event sourcing is that you always have to replay all events to get the current state. While that's true for the authoritative state, in practice we often use projections or read models for optimized querying. A projection is a materialized view of your event stream, designed specifically for efficient reads. For instance, if you have an order placed event, you might have a current orders projection that's a simple SQL table or a NoSQL document constantly updated by event handlers. This allows you to serve user interfaces and reports without replaying the entire history every time. The beauty here is that if a projection gets corrupted or a new reporting requirement emerges, you can simply rebuild it from the immutable event store. Consider an e-commerce order system. An order aggregate handles commands like add item or ship order, emitting corresponding events. These events populate various read models, one for the customer's My Orders page, another for the warehouse shipping queue, and yet another for sales analytics. Each is optimized for its specific query, all derived from the same single source of truth, the event stream. While event sourcing offers immense power, it's not without its challenges. Data migration can be complex when event schemas change, requiring careful versioning and upgrade strategies. Debugging can also be trickier, as you're dealing with an event stream rather than a direct database state. However, the field is constantly innovating. We're seeing greater integration with event streaming platforms like Apache Kafka, enabling real-time processing and complex event analytics. Serverless architectures are also a natural fit, where functions can react directly to events. The discussion around consistency models and how event sourcing fits into distributed systems is also evolving, with patterns like eventual consistency becoming more prevalent. For those looking to dive deeper, exploring CQRS, or Command Query Responsibility Segregation, is a natural next step, as it often complements event sourcing by formalizing the separation of write and read models. Also, a solid understanding of domain-driven design will help you model your events and aggregates more effectively. Event sourcing is a paradigm shift, offering powerful capabilities for building resilient, auditable, and highly scalable systems.